Question number 9. So this question is actually derived from the topic 5 of the AA curriculum, calculus. Okay, and to solve this question, we need to know how to differentiate and integrate, and also we need to know how to identify the area. Okay, so let's look at the question together. So we need to consider the function f defined by f of x equals 12x over x squared plus 2 to the power of 3, where x is a real number. And the graph of the f is shown in this diagram here. And question A, we need to show that f prime of the x is equal to 12 times 2 minus 5x squared over x squared plus 2 to the power of 4. So this question means that we need to differentiate the function f of x, right? So let's do this in other page. So here I have question A copied. So we have original function f of x equals 12x over x squared plus 2 to the power of 3, right? To differentiate this function, we can actually use the quotient rule, or we can also change the format of this function as f of x equals 12x times x squared plus 2 to the power of negative 3 and use the product rule to solve it. Okay. However, for us, we're going to use the quotient rule. Okay. So how the quotient rule works? If we have a function y equals u over v, then y prime is same as u prime times b minus u times b prime over b squared. Okay, we can use this formula to find the derivative of the function using the quotient rule. So in this case, we have f of x equals to 12x over x squared plus 2 to the power of 3. So let's set u equals 12x, v equals x squared plus 2 to the power of 3. Okay, then our u prime is same as 12, and b prime in this case is a little bit different because we have a function inside of the function. That means we have to use something called a chain rule. Okay, so how does the chain rule works? If we have something like f of x to the power of n like this, then this is same as, so let's say y equals bracket f of x to the power of n, then the y prime is same as n times f of x to the power of n minus 1 times derivative of the f of x. Okay, that's how the chain rule works. So in this case, the v prime will be same as 3 times x squared plus 2 to the power of 3 minus 1 times, we differentiate inside and multiply, so we get 2x. Then we know that b prime is same as 6x times x squared plus 2 to the power of 2. Okay, then now since we know what is u prime, b prime, we just have to recombine them together to find the prime, the y prime, right? Or the f prime. So f prime is same as, or the derivative of the function f of x is same as 12 times, which is u prime, x squared plus 2 to the power of 3, which is v, minus 12x, which is same as u. The v prime is same as 6x times x squared plus 2 to the power of 2 over v squared, which is x squared plus 2 to the power of 3 times 2. Okay, then this can be simplified as 12 times x squared plus 2 to the power of 3 minus 72 x squared times x squared plus 2 to the power of 2 over x squared plus 2 to the power of 6. Okay, then we can see that there's a common part, right? So we can simplify all this. 12 x squared plus 2 minus 72 x squared over x squared plus 2 to the power of 4, which is same as 12x squared plus 24 minus 72 x squared over x squared plus 2 to the power of 4, and this is same as negative or 24 minus 60x squared over x squared plus 2 to the power of 4, and this can be simplified as 12 times 2 minus 5x squared over x squared plus 2 to the power of 4. Okay, so what I did here is I actually factored 12 out from each term, and we have shown that the original function 12x over x squared plus 2 to the power of 3 can be can differentiate into the format of the f prime of x equals 12 times 2 minus 5x squared over x squared plus 2 to the power of 4. Then let's look at the question B. We need to find the integration of the f of x, right? So since we need to integrate the function f of x, we know that function f of x is same as 12x over x squared plus 2 to the power of 3, right? Then we can rewrite this integration function as integrate 12x over f of x as the 12x over x squared plus 2 to the power of 3. So we can rewrite this as integrate 12x over x squared plus 2 to the power of 3 in terms of dx, right? This is also same as 12x times x squared plus 2 to the power of negative 3 times dx. Okay, then from here you can see that we are multiplying the function to another function, and this other function has function inside, right? That means we have to use a substitution rule to integrate the function f of x. Okay, then let's set u as x squared plus 2. So x squared plus 2 is same as u. Then if we differentiate u in terms of x, this is same as 2x, right? Then we can rearrange this as du equals 2x times dx. Then we can say integration 12x times u to the power of negative 3 times dx, right? Then this is same as integration 6 times u to the power of negative 3 times 2x times dx. Okay, 12x is same as 6 times 2x, right? So what I did here is I separate the 12x as a 6 times 2x, so I can get rid of, or I can replace the 2x times dx with the du. Okay, then this is same as 6 times u to the power of negative 3 times du. Then we can integrate this using the simple power rule, right? Then this is same as 6 times u to the power of negative 3 plus 1 over negative 3 plus 1 plus c, right? Then this is same as 6 times u to the power of negative 2 over negative 2 plus c. Then it can be simplified as negative 3 times u to the power of negative 2 plus c. Then rewriting the u with the x squared plus 2 will give us the value of negative 3 times x squared plus 2 to the power of negative 2 plus c. And this is the answer. Okay, then let's look at the information first here. So we need to consider a function g of x defined for x being a real number. The derivative of the g is such that g prime of x is equal to f prime of x for all x value being real number. And then we're going to let R be the region enclosed by the group of the f. That means we need to use the definite integral and the graph of the g, and then the line x equals 0, and then the line x equals 3, and the area of the R is 21 over 2. So when you look at the graph of the f, we can see that this line here is x equals 0, and we can set another line or approximately around here to set it up as x equals 3, right? And we know that this is function f of x graph, and we are not sure about the g of x graph, but we can just assume that it's going like this, okay? Then we can say that this part here is the area enclosed by this information, so area, and is equal to 21 over 2, right? And we can see that the g prime of x is same as f prime of x, so this means g of x is same as f of x, but we're going to put extra constant there so we can differentiate the notation a little bit. Okay, then question C, we need to find the two possible expressions for g of x. So since we know the information that area is equal to 21 over 2, and we use the definite integral to find this area, then we know that the range is 0 to 3 for this integration process. And then since area is the region between the two graphs, we can subtract one of the graph from the other graph, but use absolute to have a final positive answer, and we can do dx like this. Then we know that g of x is same as f of x plus k, so means this is same as 12x over x squared plus 2 to the power of 3 plus k, and since f of x is equal to 12x over x squared plus 2 to the power of 3, we can calculate the g minus f part first, right? So this is same as 12x over x squared plus 2 to the power of 3 plus k minus 12x over x squared plus 2 to the power of 3. Then we can first make these terms to have a same denominator, right? Then this is same as 12x plus k times x squared plus 2 to the power of 3 minus 12x over x squared plus 2 to the power of 3, right? Then this gets simplified, and then we know the g minus f is same as k times x squared plus 2 to the power of 3 over x squared plus 2 to the power of 3. Then putting this information back into our integration will give us the formula such as 21 over 2 equals 0 to 3 k times x squared plus 2 to the power of 3 over x squared plus 2 to the power of 3 times dx. Okay, then this 2 gets simplified. Then this is same as 21 over 2 equals 0 to 3 k times dx, which is same as kx, the range is from 0 to 3 and is equal to 21 over 2. Also, we are not sure whether k is positive or negative number yet, right? So we're going to set this kx as plus minus kx, and then the range is from 0 to 3 and make it equal to 21 over 2. So we can consider both negative k and positive k. Then when we have a positive k value, then this is same as 3k minus 0k, equals 21 over 2. So we have 3k equals to 21 over 2, which is same as 7 over 2. Okay, then when you have a negative k value, this is same as a negative 3k minus 0k equals 21 over 2. So this is same as negative 3k equals to 21 over 2. Then k value is same as negative 7 over 2. Then the possible expression for g of x is same as 12x over x squared plus 2 to the power 3 plus 7 over 2, which is the first k value, or we can have 12x over x squared plus 2 to the power 3 minus 7 over 2, which is our second k value. So we have found the answer as this.